In this session, the discussion would be on power system. On the power system, the topics which we will discuss here is what line parameters and performance of transmission lines. That what transmission lines are, what are its performance, and how we will classify the transmission line, and what is mechanical design of overhead lines, and what is corona, what is skin effect. What do we mean by the skin effect, and what is balanced and unbalanced fault? Likewise, we will also discuss here the fault analysis, that in case of balancing, how the fault that has to be treated, and in case of unbalanced fault, what the positive sequence is, what is negative sequence, and what is zero sequence current component, and what is power system stability, how we are going to say the stabilized power. So what do we mean by the power quality, or the quality content which is going to delivered as a power? So what is power system stability and power system transients? So what are called to be as the power system transients? And economic load dispatch, what is mean by economic load dispatch, why a load dispatch is supposed to be economic, why there is a desire, why a desirable condition of economic load dispatch should be there while addressing any kind of load or electrical load, that is called power load. And what is underground cable, what is underground cable, what is overhead cable, why they are important, why we are going to study. And likewise, what is protection relays. So in power system there are three things, like generator, either we are going to generate the power, and either transmitting the power and distributing the power, and likewise the power protection, which is called protection and switchgear, and the utilization. And what utilization, what is the utilization of power, why we are going to utilize the power? So that we are also going to discuss here as well. And one more thing which is of quite importance, that what is circuit breaker, how we are going to discuss the relays, and when this relay is going to organize, or will be turned on, when the relay is getting to be turned on, what are those conditions when this protection relays they are going to turn on, or they are going to conduct. And likewise, what are generating power stations? So what are generating power stations, why they are supposed to be generating power stations, and why the power is of quite importance, or is of concern in generating stations, because generating stations are those stations where the power is getting to generate or develop or initialize. If the power will initialize, if the current will initialize, then and there only the transmission of power will be there, then only the distribution or the utilization of power would be ensured. And next is what is load and load curves. What is basically the load is anything which consumes power is called a load. Or what is load curves? Load curve means if there would be a variety of loads, if there would be a diversified load, then only this load diversified load is supposed to be the best optimum condition for the power system, entire power system. So in the line parameter, if we will discuss, so we will discuss that the transmission line has four parameters. Any transmission line that has four parameters, which is called resistance, and second is called inductance, and capacitance, and shunt conductance. Shunt conductance is also there, resistance is there, inductance is there, and capacitance is there. And the shunt conductance is caused by the leakage current. Shunt conductance, that is caused by leakage current, that is caused by leakage current. And it is so small that it can be neglected, and this can be what neglected. Definitely shunt conductance could be neglected, could be neglected. And power loss in the conductor is only due to series resistance. Power loss in the conductor is due to series resistance. If there will be power loss, it means that is caused due to series resistance, that is caused due to series resistance. If there would be more series resistance, then there will be more power loss. Power loss will be always addressed mostly by the resistance, because resistor is the one which is going to dissipate the power, or in terms of heat in atmosphere. So that is why this is power loss, which is only always P is equal to I square into R basically. And shunt conductance is caused due to leakage current, as we know, and power transmission capacity of the line is mainly governed by the series inductance. If we will discuss series inductance, then power transfer capability, that how much power that is going to transmit from sending end to final load consumption or receiving end. So that is why that is discussed with what the power transmission capacity, and that has to be affected by the term or the parameter which is called series inductance. And if we will discuss that, what is the corona effect? What is corona effect? Here, this is very important in line parameters. The effect that is symbolizing with the corona, the effect which is symbolized with the skin effect is getting to express. What is a skin effect? If there will be a high concentration of charges or current in the surface of the conductor, that is called skin effect. Or the effective resistance is equal to DC resistance of the conductor if the current is uniformly distributed through the cross section of the conductor. Because for DC, for direct current, there is no skin effect, because the uniform distribution of the conductor, the uniform distribution of the charges is addressed in case of DC or direct current. But in case of AC, there is a fluxing, there is a concentration, there is a what, there is a collection of charges in across the what, across the skin of the conductor, and that is seems to be what, the non-uniform distribution. So this kind of, the degree of this non-uniformity is called, is increases with increase in frequency. That is why it is called skin effect, and it is due to the magnetic flux set up by the alternating current inside. And magnetic flux that is getting to be inserted in the conductor, which is getting to be set up inside the conductor. That is why this skin effect is getting to address in case of what, transmission lines. So as we all know, in case of line parameters, the phenomenon of Biot-Savart law and Ampere circuital law, that has to be addressed, that how the magnetic flux at any point produced by a current carrying element. Suppose there is a current carrying element and a magnetic flux is always produced, because in the electric field there would be an induction of magnetic field, and in case of magnetic field there would be an induction of electrical field. That is why it is called Biot-Savart law. It is a sense of what, Biot-Savart law. And what is now the Ampere circuital law? In Ampere circuital law, whenever there is a current enclosed in any conductor, there is a current enclosed in any area. So that is what, that is expressed, by the magnetic field intensity. Or we may generally say that the current is nothing but the magnetic field generated into the current effect. If we are going to integrate these things, that is the symbolization of current only. Or current is nothing but the flow or the intensity or the force that has been imposed in any of the area itself. That is symbolized by what? Ampere circuital law. And one more thing which is important is called to be as relationship between magnetic flux density and magnetic flux intensity. Magnetic flux density or magnetic flux intensity. What is magnetic flux density? Magnetic flux density is called the number of concentrations that has to be in a place. That is called magnetic flux density. And what is magnetic flux intensity? Magnetic flux intensity is the force, is a highly symbolizing force which is experienced at any point or any area which is symbolized by H. So there is always a relationship between B and H. There is always a relationship between B and H. So how this is going to symbolize? B is equal to mu into H. B is equal to mu into H. Now we will say mu is the permeability. Permeability means magnetic permeability. It means that at any point in the material, so what ability of magnetic field lines are there? What ability of magnetic flux flow is there? That is symbolized by the permeability, means permeability. permeability, that is called to be as, so magnetic permeability, which is B is equal to mu into H, where mu is nothing but the collective permeability, that is equal to mu naught into mu r, where mu naught is the permeability of free space and mu r is the permeability of material. If let us suppose material is not there, if the magnetic material is not there, so if there is a non-magnetic material, so mu is equal to mu naught only. So the sense, the medium which is going to flow the magnetic flux is only the air or the vacuum, because whatever the number of material is, if it is non-magnetic, then there is no chances of magnetic flux flow in that material which is non-magnetic. So inductance is also there. Inductance of an inductor is the ratio of total magnetic flux linked to the current I through the inductor. So magnetic flux always symbolize the magnetic flux. Magnetic flux. Inductance always symbolize the magnetic flux. The greater the magnetic flux is there, the greater the number of the inductance that is to be there while applying some current in any material. So this is called to be as what, the inductance is there. There are different conditions where we are going to discuss flux linkages within the conductor, that what is the flux linkage within the conductor, like psi internal is equal to mu I upon 85 Weber turns per meter, and what is called inductance of the conductor contributed by flux within the conductor, and what is flux linkages outside the conductor. And in this category, inductance of the conductor contributed by flux between 2 points, let us suppose an inductance of a single phase two wire line, and flux linkages of a conductor in an array. Array means there are many more points, there are multi points, there are many number of points, and we are going to experience the number of inductance in between those, and inductance of composite conductor lines. Inductance of three-phase line with equivalent spacing and unsymmetrical spacing, or symmetrical spacing, which is called equivalent spacing. So these are the calculation of inductances, or inductances of single phase and inductances of bundled conductor lines. Bundled conductors are also there. If bundled conductors are there, then in bundled conductors more number of power that is going to transmit with high tensile strength. That is why it is called bundled conductors. And inductance of double circuit three phase line, that means that if there is an one phase, in parallel to that there is one more phase. If there is an A B C like phase, like A B C, then A dash B dash C dash phase is also there in parallel. And if there would be a transposition of those phases, then transposition is also getting to be there. That what basically the transposition means, transposition make it possible for each phase conductor to have average inductance, to have what, average inductance. So this is called what, transposition, and which is sometimes occurred in unsymmetrical spacing, that is to be addressed in unsymmetrical spacing. So what is here the mutual inductance? Mutual inductance is defined as the flux linkages of one circuit due to the current in the second circuit, ampere of current in the second circuit. If let us suppose current I2 produces lambda 12 flux. If there is a current I2 and that produces lambda 12 flux, linkages with circuit 1, the mutual inductance is equal to M12. It means that mutual inductance between 1 and 2, that is equal to circuit 1 and 2, that is equal to lambda 12 upon I2. So this is the one. So what is the current, and current is getting to produce the magnetic field, or magnetic field is getting to produce some electrical field. That is why it is called mutual inductance. And well, electrical field and potential difference is also there, and the capacitance is also there, and charging current. What is charging current? Basically the current caused by the alternating charging and discharging of the line due to alternating voltage is called charging current of the line. So that is why it is called charging current. And charging current flows in a line even when the line is open circuited and affect the voltage drop, efficiency and power factor of the line. Because power factor is always assumed to be unity, is always assumed to be unity 1. A perfect power factor is nothing but a unity power factor that is to be assumed. So for this sake, For the effect of the voltage drop, efficiency and power factor of the line, this charge current always taken into consideration. And what is the capacitance in the case of bundled conductors? The presence of ground increases the line capacitance by small amount. This note is also assumed to be herewith. Now this is all about, this is about mostly the inductance, the flow of the inductance, the flow, because in case of line parameters there are two parameters which is of great importance, which is called inductance and capacitance. In case of inductance, in case of capacitance, what are the different case studies which we are going to discuss is of great opinion. So what is the performance of transmission line? Now what is transmission line? Transmission line which is going to transmit the power, that is supposed to be transmission line. Now the transmission line may be of what? Short transmission line, medium transmission line and long transmission line. Short transmission line and medium transmission line and what? Long term. What is short transmission line? Less than 80 kilometer. If less than 80 kilometer, that is called short transmission line. What is medium? Between 80 to 250 kilometer, that is medium, and more than 250 kilometer, that is assumed to be long transmission line. So for short transmission line, effect of shunt capacitances that can be neglected. For medium transmission line, shunt capacitances can be assumed to be lumped, somehow lump sum. Or for long transmission line, distributed parameters are used. What are the parameters which are associated in long transmission line? They are of great importance and studied separately. So this is what all about. And what is now the voltage regulation? A word which is called to be as voltage regulation is of great opinion, is of great importance. So voltage regulation is nothing but VR dash. Let us suppose VR upon VR. It means that what is VR dash? VR dash is the receiving end voltage under no load condition, and what is VR is the receiving end voltage under full load condition. So receiving end voltage under no load condition, if it is minus with the receiving end voltage under full load condition, that is called what? Voltage regulation. And voltage regulation, why the regulation is important? Regulation is important to regulate some of the flows, some of the rules and regulations. It means that whatever rules and regulations, this power regulatory that has to be assumed, that is called regulation. So voltage regulation means to check the voltage, either it is supplying with that rating or not. That is supposed to be voltage regulation. That is the gist of voltage regulation. Whatever, whoever is the provider, whoever is the utility, what that utility is going to deliver the content of voltage, current or power in whatever rating, that is to be ensured by the voltage regulation. And voltage regulation is also not only ensured by the utility, but at the receiving end by whatever factor, by whatever method, if the rated voltage, power and current, that is not getting to be ensured. So by that way, by what way that is going to ensure, that is whoever is getting to decide, and by whatsoever it is getting to decide is nothing but the regulation only. So in this regard, not only the regulation is of voltage, but it is of power factor also, it is of current also, it is of everything, it is of power also. Or the lagging power factor, the regulation is positive. For lagging power factor, if the power factor that is lagging, the voltage regulation is positive, and for the leading power factor, the voltage regulation would be negative. Why the regulation is zero? It means that power factor is leading. If the power factor is leading, then regulation is supposed to be zero. So now what we are going to study is, now we are going to study the power for the transmission line. That power in the transmission line, P is equal to VR or Vs into VR, Vs into VR upon X and sine delta. So this is the power which is going to delivered from supply end to receiving end. So that is why it is called power. P is equal to Vs minus VR upon Vs upon X into sine delta. Delta is called the load angle, torque angle or power angle, and this P is equal to what? P is equal to power transmission from sending end to receiving end. So by this way, we are going to discuss the two things, basically the transmission line, the performance of the transmission line also, and this is the whole for this one session. Now in the rest of the coming sessions, what we are going to discuss, the mechanical design of overhead lines, or the mechanical design of the overhead lines, and the corona balanced and unbalanced supply, as we have discussed earlier, and many more things which we will discuss. So this is a is of great opinion that the entire power system, what it holds is many more topics which we are going to discuss. This is all for this session.